Hey guys, this is a video in my MATLAB tutorial series. In this video, we are going to start looking at Simulink. This is an introductory video where we're going to try to understand what Simulink can be used for, how to use it, and finally use it to create some simple models. In future videos, we will explore many of the features in detail. Without further ado, let's jump right into it. Broadly speaking, Simulink allows us to do computational simulations of various systems using graphical models. We'll look at it in just a little bit. You can use it for very simple systems as well as quite complicated embedded systems. One of the main benefits of using Simulink is that we can use a graphical editor to help us model the system, which may provide us a better way to visualize the interconnection between all the components of the system and understand the mathematical model behind it. Simulink can be quite useful in modeling various control systems, for example. In order to launch Simulink, you can simply go into the MATLAB command window right here and type in Simulink and press enter. Alternatively, you can also click on Home and then click on Simulink, whichever one is easier. Both should work just fine. So I typed in Simulink and I'm going to just press enter. And that brings up this screen. So as you can see, once Simulink launches, we have a few options such as blank model, blank subsystem, blank library, and so on. We're going to start with the blank model today and start by making some simple models as we get to know the interface a little bit better. You should see a library browser at the top if you have simulation selected. Let's click on the library browser, and this is what you should see. The library browser consists of blocks that we can use to make our model. Blocks are what we use to construct the model. There are sources, which you can think of as inputs to your system, such as something you're bringing in, such as data you're bringing in from the workspace, from a spreadsheet. You're giving it a pulse input, ramp input, and so on. There are also sinks, which you can think of as where the outputs are going, such as to a display, being stored in your workspace, and so on. When we click the commonly used blocks, we get to see some of the blocks that are frequently used, and it may be a good starting point for many purposes and many of your simple models. If you know the name of the block for which you are searching, you can type it in the search bar. For example, let's say I'm looking for a unit step function to have as an input for my system. I can type in step here and press enter twice, and Simulink will bring up some suggestions, and I find the step right here. I can use that. Once you find the block that you are interested in, you can simply drag the block onto the models. So I'll just drag step onto the model. If I need to use two of the same blocks, such as if I need two step inputs, I can either drag it twice, or I can click on one of them, Control C, and just click somewhere blank, and then Control V. That will copy the block that I need. If I have more than one of the same type of block, and the model Simulink names the first one as step, second one as step 1, and the third one as step 2. blocks need to have a different name so each one is distinct. You can change the name of an individual block for your model by double clicking the name and typing in the name that you want to give it. So I will say step input 1. Maybe here this will be step input 2, and maybe this will be step input 3. We can just press enter to save the name after each time you type in a name. Let's say, for example, that I wanted to have step on one line and input on another line in the title. Let's see how we can do that. So let's double click here. So let's say I wanted step, and then I wanted input 1 to go on the second line. What I can do is I can simply press shift enter, and then the cursor will move down to the second line and I can type in input 1. So you can decide how you'd like the name to show up. Another way to insert a block is to double click the blank canvas, and you'll notice that a search bar comes up here. If you know the name of the block that you're looking for, you can type it in here. For example, I can type in step, and then step will come up and a step block is inserted there. As you're starting to familiarize yourself with Simulink, it might be the best just to refer to the library browser, and if you're comfortable enough, maybe you can use this search feature as well. If you need to create annotations anywhere within your canvas, you can double click and say create annotation and then type in what you need. I can create a title here, maybe, for example. I can say this is test, and okay, I can just click somewhere else and this will be stored. I can double click it again to change whatever I need to. Maybe I can change the size, and that's that. Now we know how to insert blocks, but how do we connect them to create a model? That's actually very simple. Let's bring in a sum block. Let's go to library browser and go to commonly used blocks, and we see we have a sum block here. So I'll drag this arrow from here to the input here. So the output from step input 1 is going into the input for the sum block, and I'll do the same thing for step 2. The output from step input is going to sum block. Now, one thing you'll notice is that I cannot connect these two step blocks together. That's because they're both sources. There's no way that either of them can take inputs. So Simulink will not connect them. So that's one way you'll know that you're not connecting two things that are incompatible. If I needed to change the number of inputs this sum block is taking, I can simply double click and that will bring up the block parameters, and notice there are 2 plus signs here. I can put a third plus sign, and you'll notice that I get an additional input. I can also change the size of blocks simply by dragging them in the corner like this. So now this can take a third input as well. Let's say that 2 of them I needed to be plus and 1 of them I needed to be minus. I can click on this and then go here and make this the minus. So it will change the minus sign in the respective place. Let's start modeling some systems. I'm going to left click my mouse and select everything on my canvas and press delete to get rid of it. You see now everything is selected, and I can just simply press delete on my keyboard and everything is gone. Let's start off with a very simple mechanical example. We're going to consider a mass on a spring. Let's look at this example. A spring that complies with Hooke's law is fixed to a ceiling. The spring has negligible mass and an unstretched length of 7 times 10 to the negative 2 meters. A block with a mass 1.2 times 10 to the negative 1 kilogram is suspended from the bottom end of the spring. After oscillations have died down, the final length of the spring is 8.6 times 10 to the negative 2 meters. Find the spring constant. Well, since this is a Simulink exercise, I have already created the free body diagram and come up with the formulas that we're going to use in the model. So we have the spring suspended from the ceiling, and we have the mass, and we have the initial length, and then we have the final length. So L naught and L1. And when we look at the free body diagram, the force acting on the spring is gravity in the downward direction, and the force of the spring in the upward direction. And force of the spring can be modeled with Hooke's law, which is K times final length minus initial length, or the stretch of the spring. So we have K times L minus L naught minus mg equals 0, because the mass will be in static equilibrium once the oscillations have died down. So we have K isolated for K equals mg over L1 minus L naught. This is what we need to model in Simulink. One quick note is that in this problem, although I forgot to write it down, I have defined the upward position or the upward direction as the positive direction. We don't need to create a Simulink model for this very simple problem. However, this would be a good opportunity to see how a model is made in Simulink. I'm going to open up the library browser, and we're going to insert some constant blocks. So, what are the knowns in this problem? Well, we know that acceleration due to gravity, which is g, is constant. So that's acceleration due to gravity. And what else is constant? The block's mass is constant. So first, let's change this value. This is going to be 9.81, and we're going to apply that. Click OK. And we're going to copy this block and just paste it in again. It's Control C and Control V. So I'm going to make this, change this value to 1.2 times 10 to the negative 1, because this is in kilograms. And it's sorry, the block's mass was 1.2 times 10 to the negative 1 kilogram. So we'll apply that and click OK. And you'll notice that I got a C and not the value displayed. That's because in this current size, the value is too long to be displayed. So we can just make this a little bit bigger, and you'll see that the value comes up. And I'll change the name. I'll say this is block mass in kg. Okay. What else is constant? Well, the final spring length is constant, as well as the initial spring length. We can do this one of two ways. We could just give the subtracted or the stretched value as one input, or we can have Simulink do it for us. And I'm just going to do it that way. I'm going to this time I'm going to just go to library browser and insert blocks, just to show that there's a different way to do it than copy pasting. So now we can change this value to the final length of the spring. The final length of the spring is 8.6 times 10 to the negative 2. We'll apply this. We'll hit OK. Once again, we'll make this block a little bit bigger and make sure we change the name. This is going to be final spring, and I'll press Shift Enter to type in length in the next line, length, and this is in meters. This time I'm going to copy, Control C, and then just Control V the block. So now I have two blocks that are exactly the same, and the names are exactly the same. So Simulink gives it a 1 to distinguish the names of the two. But this is going to change very soon. So this is going to be 7.6 times 10 to the negative 2. Apply that, click OK, and this is the initial length of the spring. This is also in meters, but we can get rid of the 1 now. Okay, so now we need to do some operations. First, we'll include a sum block. So let's go to the library browser again. Let's bring in a sum block, but we don't want to add these two values. We want to subtract them. So I'm going to click on this, change the second plus sign to a minus sign, and you see that now I have one being added and one being subtracted. So this one is the final spring length. That one will go into the sum input, and this one will go into the minus input. Now what I'm doing is I'm taking final spring length minus initial spring length. Now I'm going to include a product block. So let's type in product here. And this is the product block that I want. I could also take the divide block. So I'm going to take the divide block actually. So I'm going to click on it. I'm going to say multiply twice and then divide once, because I need to multiply two things together and then divide by something else. I'm going to multiply acceleration due to gravity times block mass, that's mg, and I'm going to divide it by the stretch of the spring, and that was the formula that we have for k. K equals mg over L1 minus L0, and that's exactly what this is doing. And this output should be the value we have for k. So I'm going to go in library browser, go into my sinks, and I'm going to insert a display here. I'm going to connect these. So this, I'm going to change the name of this. This is the spring constant k. And just a quick note, the unit for the spring constant is Newton per meter. In this case, we have a 9.81 meter per second squared times kilograms, and then that's going to get, mg is going to give us newtons, and then we're dividing it by meters, so it's Newton per meters. So units are very important, so we'll include that as well. And let's put parentheses around this as well. Okay, so now we have this. So now once we have created our model, all we need to do is press run. And we get our answer. It's 117.7 Newton per meters. Also, you can also change the appearance of these blocks. As of now, they're all just plain white blocks. I can, or just taking the background of the canvas. So what I can do is I can click the block, go into format, and then click background and choose a color. Let's make this orange, for example. Let's click on this. We can make that green. Let's say that's yellow. Just randomly selecting colors. This is this color. Just choose that to be the shade of blue. And let's choose this to be magenta. The answer should be bright green, let's say, or something like this is fine. Okay, so you can see that you can also change the appearance of your blocks. Let's clear this model. We're going to start with something new. So I'll just select everything here and press delete to get rid of it. Now let's do an exercise where we combine a pulse generator source with a sine input. I just simply want to see what the output looks like. This time I won't be able to use a display block. Rather, I'll use a scope. So let's go into library browser again. I'm going to go in my sources and see if I can find a pulse generator. There it is. And I'm also going to include sine inputs. I'm just going to type in sine here. You'll notice that we have a couple of different things. We have trigonometric function sine, we have a sine wave function, and then we have the sine wave. Notice the difference between them. This is the trigonometric function, so you give it an input as if you're typing in sine in your calculator, and it will give you the output, like sine of 60 degrees, for example, or sine of pi over 2 radians, or things like that. And this is a sine wave function. And this is the sine wave input that we want. Notice that this one doesn't have any input. This is not capable of taking inputs. I can only give you outputs. This one takes inputs and gives you outputs. So we're going to use this. So these are two sources. Now we're going to change their parameters a little bit. So the amplitude is 1, the period is 10. I'll leave the amplitude as 1, but the period I'm going to change it to 1 second. Okay, let's apply that, and let's hit OK. I'll also click on the sine wave. I'll change the amplitude to 2. Put on apply and click OK. Click OK. And now I'm going to sum these two together. So I'll go to commonly used blocks and just insert the sum block here. I'll add them together. And now I cannot use a display to view this because this is not a constant value. It's changing throughout the simulation. So I want to see that, so I'll use what we have as a scope. So this scope will allow me to see changing values throughout the simulation. So I will run this, and then I'll click on scope, and this is what it looks like. Kind of interesting. I don't know what this is the shape of, but it's something I randomly made up. It looks kind of interesting. But the point is, we can track the values of the input going into the scope throughout the 10 seconds the simulation is running. Let's this time let's keep the scope open. I'm just going to change this value to actually, I'm going to come here and I'm going to change the period to 0.5. Click OK. Apply an OK, and keep the scope open and run this simulation. And we can see that I didn't need to close out and open again. The same scope window updated. We have gone through some introductory concepts in this video. In future videos, I will cover more Simulink concepts. I will also continue adding more videos to my MATLAB tutorial series. If you haven't already, check out my MATLAB tutorial series as well as the various calculator tutorial series on my channel. Please subscribe. Until next time, take care, guys.